Okay, we have a number of attendees already here. Shall we begin, folks? Great. What an exciting and timely webinar we have this time here at buildingSMART USA. Um, an immensely important topic, which is combining openBIM with GIS to give more meaning, validity, and utility to our digital twins. We are extremely fortunate to have a distinguished panel here with Mark, Michelangelo, and Will. Mark Goldman, as many of you will know, has been in our industry for 3 decades now and is currently Director of AEC Industry Efforts at Esri. So Mark, can you take it away and help us get started?
My absolute pleasure. Thank you, Tony and buildingSMART USA, for this opportunity to do, like you said, talk about a subject that is very timely. Just a few years ago, the idea of GIS and openBIM or GIS in AEC was kind of on the sidelines, but it has become front and center. I'm actually at Esri's user conference in San Diego right now with about 18,000 of my closest friends. Professional friends at least, and the topic of GIS in planning, design, construction, operations is just a hot topic here. And I'm gonna talk about that. Before talking about kind of where we are today, I like to always start with accolades to those who got us to where we are. This is a photo of Ivan Sutherland dating back to the 1960s, I believe, with a product that he developed called Sketchpad. You can see him with this little stylus on screen, a computer the size of a VW wagon, probably, drawing out a 3D views, multiple views of a chair. So earliest days that many people will say of CAD. A couple of years later than that, this would have been the computer you would have been working on if you were doing anything related to, let's call it digital mapping, although I think that's maybe a stretch as far as what this really is. 10 years later, 1980s, you might have a computer such as this. This is around the era that I got into CAD on a similar type of system with a giant tablet and a keyboard, and I even had a joystick to work with. And here you can see some early GIS, state of Louisiana, showing up in a couple of screens. A couple of years later than that, this would be your state of the art for generating maps. This, although I can't tell it other than the label, this is Boston, which is, we've come quite a way in the ability to present maps out of our computers onto paper. Around that era, I was also getting into the earliest days of CAD. Here's a version of AutoCAD from the 2-point-something version, which was when I first got my fingers on AutoCAD. Around that same time, maybe a few years later, Esri came out with a product called ArcMap and ArcView. Again, Louisiana seems to be the common theme here. And this was about as high tech as you could get as far as the ability to put together layers on a screen, projecting some imagery combined with vectors. And around that same time, I actually got my hands for the first time on GIS. I was in actually Louisiana. I went to school at Tulane University and was asked to work on a project bringing together CAD floor plans and incorporate them onto some maps showing where properties that potentially could be converted from defunct, dilapidated, abandoned properties into potentially community resources for churches or for schools or for playgrounds. And just the effort to bring the most basic CAD into the time the most probably advanced GIS took weeks, literally weeks of DXF exporting and coordinate resolution and transformations and rubber banding of the images underneath. It was just an absolute challenge. Here we are around that same time as CAD started to become more than just basic lines, arcs, and circles and blocks, but actually multiple scales, multi-views, paper space, and model space all combined. In that same era, the 2010s or so, GIS started to get into 3D, but not nearly the quality that we'll see today, and you'll see in some of my examples. Roughly the same time frame. Here's Autodesk Revit 2010. I was just leaving Autodesk for my second round at Autodesk, and you can see early versions of Revit, getting from basic CAD into true model-based design. And just 10 years later, here's where we're at, early 2020s. This is a dashboard put together by one of our product managers, bringing together 3D-based BIM into dashboards, connecting it, schedule information, field data collected through mobile devices, reality mapping, reality capture, overlaid with the BIM, allowing you to see the progress of construction in a dashboard made up of all the different views that a construction planner, construction manager might want to see, truly delivering on this concept of digital twins. My path to GIS was probably like many folks in the AEC industry. It was on the sidelines. You had your heads down in your CAD and BIM and scheduling software, and GIS was at best known to be a mapping tool, but it's come so far in those years. We're still generating maps, but those maps become apps, and those apps lead to insights and dashboards and decision-making, and we're just so much more than the basic mapping capabilities that if you had any experience with GIS, you hopefully now are seeing that we're so much more just by a couple examples that I've shown and more that I'll be showing here. Over the last decade or so, Esri has been investing in integrating BIM with the flagship product ArcGIS, beginning with the ability to import through an ETL type of workflow into our main product, desktop product, ArcGIS Pro. That has evolved over the years as we've strengthened our partnership with, amongst others, Autodesk, who we have a very strong relationship with, and we're reading Revit files directly, DWG files, and certainly IFC files as well. Those came around just a few years ago, and we have invested significantly in people and energy and commitment to buildingSMART International, buildingSMART USA. And I think you'll see in a few examples that I'll show in some live scenes how well we are bringing in IFC data from various authoring applications into our scenes. And then you're going to see some great examples from Michelangelo from ACCA Software, who's really going to, I think, blow your mind. So ArcGIS Pro, I've mentioned it a couple of times. My philosophy is if you're using a BIM or CAD application, a product like ArcGIS Pro, right next to that, pulling it out of your toolbox to take that CAD and BIM information, combine it with satellite imagery, combine it with reality capture data, combine it with literally thousands of layers of data that you might want to use to understand the project better, to get a context of your designs in the real world with layers of information, which might typically be non-graphic, census data, traffic flow, weather patterns. That type of information combined with your designs really just opens the door to better visualizations, better deliverables, and the ability to share. We developed a product about 2 years ago now called ArcGIS GeoBIM, which takes the 3D content you might create in the likes of a Revit or other modeling applications and connects the Esri cloud, ArcGIS Online, to, in this case, the Autodesk Construction Cloud or BIM 360, so that in the left side, you're looking at a map-like view with all of the context, and on the right side view, you've got the Autodesk Platform Services, the Forge viewer that allows you to interrogate, understand, access all of the other documents that might be connected to your project. So again, delivering on that concept of digital twin, various layers of information, various scales of information in near real time through a single application that is not just the proprietary formats, but also IFC is consumed and read and understood in GeoBIM. And then another application that has really caught my eye at Esri called ArcGIS City Engine, that is a parametric computer-generated architecture modeling application for city scale, multi-blocks, regions, entire cities, modeled out with parametrics. And it is also reads and writes IFC formats, a little bit behind Pro, which is up to 4.3 addendum 1, I believe. City Engine is still at 2x3, but I'm pushing to make that the latest and greatest 4.3, 4.4. So why are we putting this energy into GIS for AEC? I've kind of touched on it, that the context of planning, designing, constructing, eventually operating capital projects, assets are based on spatial information. The idea of these projects existing somewhere along that life cycle is something we sometimes kind of gloss over. The design and engineering tools that typically are used start with a blank screen, but if you could bring in a map, if you could bring in some of those layers of information to help inform those earliest decisions that you make before you put a line on screen that represents a wall or a roadway or a bridge, you know, your first decision is going to be more informed. GIS also acts as this integrator of content. I can't really think of an industry, a set of professionals who deal with more ranges of information, types of data, complexity of information than those who are involved in building out our infrastructure. You know, CAD data is very complex. BIM information, you know, adds a whole nother level of complexity. Schedules that need to be understood in Gantt charts and various types of visualizations. All the PDFs that need to have information extracted from them. Spreadsheets, and I can just go on and on of all the information. Point clouds, photogrammetry. GIS brings that together, and location acts as a common denominator to bring information into a single view to be analyzed. And what I've seen over the few years here at Esri, I've been at Esri now for about 4 years, that when you're able to bring data together, you end up bringing people together. So no longer are you just throwing your information over the fence, hoping that it can be understood as a file, but you're actually connecting around services, web services, data services. It enables a level, and it requires a level of communication and collaboration, which is the driving force, I think, of the digital transformation that's happening in this industry. And I don't just mean going from perhaps paper to dumb PDFs, but actually changing workflows around data and around digital workflows so that information is retained and maintained and persists and becomes this golden thread, to use a buzzword, you know, it's typically related to digital twins throughout the entire project lifecycle. This integration of data and apps has become required. No longer is it just the leading AEC tech-driven firms that are adopting technology, but owners themselves are forcing this digital transformation. They're expecting to be kept in the loop. They are demanding to know project status way ahead of what they typically knew and what they typically would see with project schedules that might be 6 weeks out of date. This expectation of data and digital methods during project delivery is also driving this digital transformation. And I think that gone are the days of tech shaming our industry, of you know, feeling ashamed for the lack of adoption of tech amongst AEC professionals. I think those days are gone. I've seen it statistically, I've seen it anecdotally, and I've certainly seen it with the solutions that are coming out from Esri and all the partners that we work with. So with that, I want to jump over to actually a live app that I put together. This is using a solution called Story Maps that allows you to bring together maps and web scenes and images and videos and timelines, and certainly lots of text to help tell your story. So what I've done here is I've worked with one of our project engineers who is much more fluent on our software than I am to put together a few scenes, but I actually got to admit, I've done a fair bit of these maps myself. So this is a scene in San Francisco where I've just taken, you know, picked a region, picked a base map that in this case is imagery, and zooming in on a portion of San Francisco along the Embarcadero that you can see what I know is Pac Bell Park. I think it's Oracle Park. I don't even know the name of the stadium now. But simply chose to use the open source OpenStreetMaps 3D buildings as my base layer, and then brought in an IFC file 4.3 that I believe was generated in Civil 3D.
Sorry, Mark, I'm gonna interrupt you really quick. We're not seeing app. Yeah, we're
okay. Thank you for stopping me. Let's see. It's because I didn't share my whole desktop. I really appreciate you doing that before I got too far on the road. Okay, so we're just going to start out. Okay, so here we are. We're in Story Maps, and here's that scene in San Francisco, Pac Bell Park, as I still call it, OpenStreetMaps data. And this is a live scene. This is an actual 3D map that I can interact with as a means of collaborating with my team. Here we're zooming in on that particular model that I mentioned. And we bring these in through our geoprocessing tools that allows us to simply find a file, quickly import it, quickly export it into just tons of different file formats. but GIS tends to be more data oriented than file oriented for the most part, at least these days. So we've got this model here that we could look at from different views. We can click on the objects. We can see the properties. There's not a whole lot of properties on this. It was just a test case. And that's what I'm going to be showing, mostly kind of these test scenarios. I can navigate around my model, turn on and off from the generic trees to the more detailed trees. I can isolate the model. I can turn off the buildings around it. Again, this is a 3D environment. It's not just a static image. It's not just a video. I can explore the content. It is a GIS environment comprised of, in this case, IFC 4.3 data. Here's another model. We went to, we being a few folks from Esri, the buildingSMART Rome Summit, and prior to that wanted to have some good examples of IFC data brought into our environment. So here we're looking at a similar situation. I happened to stumble across on a webinar. I think it was actually a webinar that ACCA software was running, had a really great model that I wanted to show. So reached out to our friends there and said, hey, can you help me get that model? Got it as an IFC 4.3 file and brought it in, did a little digging around, and they actually shared a couple models. This is just one of them. And you can see here's the model in BIM Collab. This is the model back in ArcGIS as an ArcGIS online web scene. And again, the same kind of capabilities, change my view, change my environment, change my layers, and just come to understand the content the way you would in any kind of BIM visualization tool. GIS has become that as well. And it's not just visualization. I'll get to some other examples. Here is a Vectorworks model. We're also partnered with Vectorworks. I was recently in Rotterdam, so this feels somewhat relatable. I biked around the town, asked our friends at Vectorworks for some IFC data, combined it with some OpenStreetMaps data. This I was just working on yesterday, actually, with our project engineer. He just received the file a few days ago. So multiple IFC files are brought in this case, from Vectorworks. Here's what it looked like in BIM Collab, and typical of BIM viewers, that there just isn't context to the model, as opposed to what you're seeing here in a 3D web scene. So I've got the structural model, I've got the architectural model, and I think I've got the mechanical model as well, all isolated. And it's just a matter of turning on and off layers, not too different the way you might do it with AutoCAD. But in this case, you know, these layers are comprised of features. Features make up GIS, and features can be analyzed a whole lot more ways than you could typically do in a CAD or a BIM application. We're also working with Bentley. Here's a screenshot from On-Roads, I believe. Again, this is a live model. Turn on and off some layers, change the transparency. In this case, the model was not geolocated, which is often the case with BIM content. It is not geolocated, but it is known where to be located on Earth. So we have the easting and northings. We entered those into our software, and the model gets placed in context, change my views. And again, you know, yet another application where I can just click on the objects and see the properties of those parts and pieces. Finally, this was an interesting one. Got to Rome, saw a company called CSFPEA, and they had some really cool bridges, I think IFC 4.0 format. So went over to their booth in their best English and my best Italian. We ended up exchanging a file. They provided an IFC file, let's say on a Monday. And by Tuesday, when I had my presentation, we had this model to show on screen and demonstrate essentially what I'm doing here. Just, you know, being able to highlight the fact that IFC 4.0 content coming in to these GIS environments for exploration. Before jumping over to Michelangelo to show some demos of the ACCA software, I just want to show a little video here, just about a minute long, that they're doing some brilliant things, bringing together BIM into GIS views for a whole bunch of purposes. He'll get into that right after me, but I do have a few more PowerPoint slides I want to show before handing it over. One is a company here in the States, HNTB. They have been building bridges for 100 and something years. They had a particular bridge in Norwalk, Connecticut called the Walk Bridge. It's a lift bridge, roughly 80 years old, I think, that they're replacing with a new bridge right next to it. They're doing pile driving next to this old bridge, you can see these little blue sensors that pop up on the screen. These actually represent IoT sensors. So the blue columns represent the height of data coming in from IoT sensors. This is a model comprised of Revit content and DGN content from MicroStation, as well as GIS environment. So it's not necessarily openBIM, but it is, I think, a great example of digital twinning of sensors providing real-time data in context in a 3D model with GIS information, so that as the pile driving is occurring right next to this old bridge, they can see whether or not it's creating the seismic conditions that should keep the project managers from allowing the pile driving to occur. So here you've got temperature data, XY tilt information, seismic data associated with the sensors. Another example, this is GIS plus openBIM developed by Pomerleau Construction. Actually just ran into the project manager on this just about an hour ago. Pomerleau is based in Canada. They combine BIM information and GIS views. They put sensors into the concrete so they know the curing strength in real time of the concrete, so they don't either start raising and erecting steel too soon or wait too long. They know exactly what is going on in their project by combining the IFC models in a GIS environment with IoT data. And I think by many definitions, that is digital twinning. And this is one of my favorites as well. Skanska UK infrastructure team bringing together, in this case, IFC is their language for translation between AutoCAD-based applications, MicroStation-based applications, and others. They use our tool called Survey 123 to go out in the field, collect existing conditions for construction design management requirements. All these little red dots on the screen show locations where issues were identified in context to the actual design, so they know whether there's a water condition or a soil condition or any existing concerns they should have before they solidify the design and start construction. So again, I think this complies with most definitions of digital twins, a virtual representation of a physical environment with data that's being collected on a predictable basis at an expected fidelity, helping to inform decision-making. Similar scenario also from Skanska. This is a different project, but similar concept combining BIM, GIS, sensor data, field data collected, informing the project team in context in a dashboard that you can navigate, as easily as you could navigate SimCity, let's say. So with that, I think I'm right on time. I'm going to hand it over to Michelangelo from ACCA Software. I've gotten to know them over the last year or so. They're actually here in San Diego as well. I'm very impressed with what his company is doing in the world of bringing BIM and GIS together. And I think you're going to see some great stuff. So take it away, Michelangelo.
Thank you very much, Mark. And hello, everyone. I would like to continue in this presentation of different use cases that we have seen so far and bring to your attention our technology, which combines openBIM and GIS to deliver what we think is and should be a digital twin. This technology is called ASBIM GeoTwin and is the dynamic connection between the ArcGIS platform from Esri, which is about the GIS side, and the ASBIM platform from ACCA Software, which is all about the BIM side. Before going into the details, just a quick introduction of the company. Basically, we are located in Italy, in the south of Italy, near Naples or Rome. And this that you are looking at is our new headquarters. Basically, ACCA is born 30 years ago, and in Italy is market leader for the AEC industry of about software house. And in the last few years, we embraced the openBIM technologies and methodologies, and so we are expanding to the international market as well. We are putting a lot of efforts in the openBIM ideas, and we try to develop as much as possible new solutions and integrate existing solutions with the guidelines from buildingSMART. We are multinational members of buildingSMART. We are now over 200 employees, and we have more applications certified for IFC import and export than anyone else. So again, ACCA has been historically present always on the Italian market, but we are expanding to the international market as well. Today, among the different technologies that we have, I would like to talk about the integration between the openBIM and the GIS platform from Esri. And basically, as I said before, this is very important for us because openBIM, we believe so much in openBIM that this has been our mission in the latest year, to transform BIM into openBIM, because we really think that it's that openBIM basically is the way to go. And so before looking at the use cases, I don't want to make this presentation technical at all. I just want to point out why it is a dynamic connection between the two platforms and what is that differentiates us from other solutions. Well, dynamic means that there is no static exchange of data between the two platforms, but everything happens in real time and using APIs, which means that every time that there is an update on the BIM side, because people are working on BIM models and updating them, then everything is reflected and updated in real time on the GIS side. So basically, this allows us to develop a system, a layer of technology, basically with unlimited scalability in mind. So in theory, our goal is to have the possibility to gather all the construction data around the world and to be viewed all of that in a single GIS digital twin. For us, it means to have IFC openBIM models, whether they are of buildings and infrastructure, so railways, roads, bridges, and so on, up to the newest schema, the IFC 4.4, the one for the tunnels. Of course, we can also handle different file formats for visualization, but the real focus of the use cases will be about the openBIM IFC format. Based on what we have seen so far, of course, we can combine such different input formats to be viewed together. So here we are looking at cloud point and an IFC model viewed together in the same GIS view. But again, I would like to point out the fact that this kind of separation of duties we think is very important because allows the user to continue to do what they have always done, which is to update the model during all the asset life cycle and to reflect all the changes, the updates in real time in the GIS view for the GIS user to make their queries with the up-to-date data in real time. So yes, the changes are reflected in real time during all the asset life cycle, and whenever there is the need to do special analysis from the GIS side, the GIS side queries the BIM models, which will return the up-to-date data, so that the results basically will always reflect the actual status of the building using the latest information. Of course, then when you have the result from such queries, which are based on openBIM and GIS data, you can visualize them in the same environment, so combining the BIM and the GIS view. And since you have the data, you can have all the algorithm and the data analytics running on the data that you have gathered. This is the basis, it's the foundation, because on top of that, since you have these small building pieces, let's say, Then you can think about more complex use cases. One that we are talking about, and it's still in development, and there is a lot of work to do, but is definitely possible, is, for example, the digitalization of the permitting and the compliance processes by combining both the openBIM and the GIS data, as well as possibly other data sources, such, for example, data that can come from the asset and facility management, or the Internet of Things from the sensors, like we already have seen also before. And of course, last but not least, it is possible to navigate the openBIM models directly in the GIS environment with the use of virtual reality. I would like to show you everything we have seen so far in a video, which I hope will clarify even more and show you all these possibilities in some examples that we have prepared. So let's start simple by looking at an IFC model on the BIM platform. Actually, this is not a single model, but it is a federation of multiple IFC models. So we have the architectural, the structural, and MEP models. Of course, this is an IFC model, which means that every object has all of its properties and characteristics. And then we can put the same model in place on the GIS view, on the GIS map. So this is basically the same building that has been copied over and put on a map. Here we can see that all the information, you can actually click on the object and query the BIM system, which will return the properties for that object in real time. So actually, if someone, as we will see later on, will update the model, then the result will be different. And of course, all the functionalities that you can expect from the visualization point of view from the BIM platform, you can have also in this combined view of GIS and BIM. So here, basically, you can play with the visibilities and colors and all the that kind of stuff. This is another example, quite an extensive one. This is the city of Barcelona, which has been reproduced in 2000 IFC models. Here you can select each building and see their properties. You can see that the geometric level of detail is not very complex, but of course you can start with this to have this large scale, and then when you have the single and more detailed IFC models for each one of the building, you can substitute the low fidelity model with the complete one, like in this example where we have a complete model for one of the buildings, which again is composed of the architectural, structural, and MEP part. So basically, you can think about the unlimited scale of the digitalization of the. We have seen the whole city of Barcelona. This is another example in Morocco. This is a bit different because it uses cloud points and texturized meshes. So we are combining different formats for viewing purposes, but in the end, the data, the real data, is in the IFC model, which is the one that we are looking at. Another example here, we start to see some of the use cases that we have talked about before, because as I have seen, as I have said already before, the important thing is that when the BIM user updates the model somehow, then the changes are reflected in real time. Here is an update of the federation of the models, where we add another building to the scene. So we have done this operation in the BIM platform, basically, and the update is reflected in real time on the GIS system as well. So this is an example. We will see also later on some others, but again, here we are talking about geometry, but also if you update the data, then the model gets updated. And this is very important because here we see that we are start combining the data coming from the layers from the GIS and the openBIM platform. Here we are integrating a third system, which is the facility management system. So in the same view, we have the GIS system, the BIM system, and we are talking with the facility management system. So we are selecting, for example, one of the assets, and we can query the facility management system. So we are looking at the tickets that are open, who done the maintenance, when, and so on. And again, everyone is doing their job. There is no, the data is not copied over into the systems. So if someone updates the facility management system and you query the object again, then you will get the data up to date. And we have seen before the exploration of the models with the virtual reality. This opens up a lot of other use cases. The first one that comes to my mind is when you have to do some maintenance and you want to inspect the site before actually going. So you can use a virtual reality to explore the site before actually going. But there are many other use cases. We have seen so many buildings so far. It's not all about buildings. It can be also, of course, about infrastructures. This is another example where we have the Naples Railway Central Station. These are 56 models, IFC models, that have been created by Minucci Associati and that reproduce the Naples Central Station. Again, you can click on each of the objects and you can see that we are connecting to other external information such as images, documents, and so on. So again, we are querying different system and putting everything in place with in the GIS view. Another interesting example is about bridges, and in particular about the possibility in general to use IoT sensors on bridges. So here we are connecting to an IoT system, so to some IoT sensors, in which we specify a color map, and since each of the sensor is connected to one bridge entity, we can actually color the entire bridge based on the real-time values that are returned from the sensors. Here there is a lot of research that we are carrying out with some universities here in Italy, and this is a very important topic. And you can think about not only at the single bridge that you are looking at, but you can think about it to scale on all the bridges of the country, for example. So we are looking at ways to make the data available and to scale on a territorial level. This is another example. This is IFC 4.3. This model has been created in the project that we have done in collaboration with the buildingSMART Italy working group. And it is a model of a road, and you can have also seen a tunnel with a very low geometry level of detail. This instead is an example of an actual IFC tunnel that we are developing in one of the latest working groups from buildingSMART International, which is about the new version of the standard, which also features tunnels among all the other linear infrastructures. And we have already seen some examples of the bridges. Here is another example, and again the possibility to navigate the environment with the use of virtual reality, so navigation and exploration in the GIS view of the BIM IFC models. One of the cool things about IFC is the fact that you can have very different kind of assets represented. This is a power plant, for example. But the good thing is that since it is a standard, the data is available in a standardized way, which means that the query that you do for one model work almost without modification with other kind of assets as well. And this is very, very important because it means that you can have a very different kind of assets and not worry too much about the details of the models. Of course, some modification are needed, but in general, this is one very good thing to have. We have seen a point cloud of a football stadium before. Now we are looking at a 50-kilometer railway, combining the point cloud with the actual IFC model. So we can always select the objects from the IFC model, and we are looking at both the model and the cloud point. And we are navigating the model in this way. I've talked about the possibility to develop complex use cases such as the permit and the compliance processes. Of course, when you have available the GIS data from one side and the openBIM data from the other, then you can think about doing spatial analysis queries. Here we are looking at some simple example where we are querying based on a radius about around the building in order to find different kind of rooms or compartments, and the type of that rooms and compartments. It may seem a real simple use case or real simple query, but having the possibility to do that will allow you to build more and more complex use cases. And again, I have said already this before a couple of times, but I want to conclude again with this, is the fact that this opens up the possibility to have the BIM user to continue to do what they always have done, which is to update the model during all the asset life cycle. And on the other hand, the GIS users will see those changes reflected in real time. So it is not a disruptive workflow, but something that enhances the possibility. So to conclude, what we have seen is the use of GIS maps and combining them with the FC models and point clouds, and in order to do spatial analysis on the GIS and the openBIM data, and also by using asset and facility management, IoT, and the data coming from other data sources. So this is what we think is a digital twin, and the basic use cases that we have presented so far. We hope that will open your mind to more complex ones. Let me present myself at last. I am Michelangelo Cianciulli, and I am openBIM and IFC expert at ACCA. I thank you very much for your attention, and I will leave the floor to Will Sharp, which is Senior Vice President and the Global Director of Highways at HDR. So again, thank you very much.
Thanks, Michelangelo. Let me get my screen shared here. Okay. So we need this one. Okay. All right, there we go. Now, great presentations, Mark and Michelangelo. And of course, I'm Will Sharp. I'm with HDR. I'm also co-chair of the buildingSMART USA Roads and Bridges Industry Committee. And certainly what you guys are doing with tying in IFC and GIS is just critical to what we're doing on the roads and bridges industry side. So with the interoperability that opens up, so just great presentations. I asked for a couple of minutes today just to give you an update on what we're up to with the Roads and Bridges Industry Committee. I was hoping to have Mike Bosselman. Mike is with Montana DOT. He's the CIO of Montana DOT and also the chair of the AASHTO J-Stand Committee. I was hoping to have Mike on the line today, but unfortunately he ran into some travel issues and was not able to make it to the webinar today. So just wanted to give you a brief update of what we've got going on here and start off with our vision with roads and bridges. You know, really, what are we trying to accomplish? It's really a national vision for standardization, and it's trying to tie the data together from design to construction, fabrication, into asset management. And I can tell you, I personally work in the design area, and oftentimes we do great information, you know, 3D models, attributes, lots of information. It all gets translated to 2D PDF plan sheets and it gets lost. You know, so we're really trying through openBIM to tie it all together and really leverage and build on that data throughout the entire life cycle through openBIM. So a couple of updates on national progress to data standardization. A lot going on in the transportation industry in this area. There's 2 national transportation pooled funds that have been created, BIM for bridges and structures and also BIM for infrastructure. Those are really help driving things at the national level with the state DOTs. Also, AASHTO back in 2019 at their annual meeting, a couple things happened there. They adopted IFC as their national standard for the state DOTs. Of course, IFC is the ISO compliant, you know, international open data exchange that, you know, was discussed earlier on this. They also formed a new group called J-Stand, the Joint Subcommittee on Data Standardization, to help coordinate how they're going to implement IFC throughout AASHTO. So that was really foundational to moving ahead. And then one other thing I wanted to note is 2022, the AASHTO Committee on Bridges and Structures actually adopted a national standard for the open exchange of bridge data. And this was for the use case to go from design to construction. And all 50 state DOTs balloted this and adopted this national standard, you know, that will be based on IFC. So great progress there on the national side. I also wanted to touch on, you know, how does the Roads and Bridges Industry Committee, how are we working with the state DOTs and AASHTO? And this graphic summarizes that relationship. You know, this is something that we've worked quite a bit on with Mike Bosselman with the J-Stand Committee, and also Mike Kinderly with the Joint Technical Committee on Electronic Engineering Standards, and just really mapping out how we're going to work together between our committee and all the AASHTO efforts and full fund efforts and committee efforts. So this summarizes this. A couple things to highlight on this graphic. We do see the J-Stand Committee, the Joint Subcommittee on Data Standardization, is critical to our efforts coordinating with the Roads and Bridges Industry Committee. That J-Stand represents really the life cycle use of the data. So they have representation from AASHTO on the roadway side, the bridge side, construction, asset management, AASHTO-ware, and data management. So it really covers all those core areas with AASHTO. I also wanted to note in this graphic as well is that AASHTO did join buildingSMART International as a principal member. Mike Kinnerly is leading that interaction with buildingSMART International as a representative of AASHTO. And I know several other people from AASHTO are involved as well, including Mike Bosselman and Bill Pratt with Connecticut DOT. So a lot of activity going on here as AASHTO gets more integrated with buildingSMART, you know, both on the operations side, working with the different rooms, as well as the governance side and the actual IFC schema. One of the key things I wanted to highlight for you as well was an openBIM workshop we had at the FHWA BIM Week earlier this year in Washington, D.C. So what we had is a half-a-day workshop that we briefed representatives from 21 state DOTs and Federal Highway Administration on where buildingSMART International is going with the infra room and the infrastructure roadmap, and really also getting U.S. input to that roadmap. You know, that roadmap is really what we're using for the next 5 years. So this was a great interactive process to really present, you know, ideas from other countries, get U.S. input. And I know Mike Kennerly presented a summary of this input at the buildingSMART International Summit in Rome earlier this year. So it's great to see AASHTO and, you know, the U.S. transportation industry really getting more involved with buildingSMART USA. And this workshop, by the way, was jointly hosted by buildingSMART USA and the AASHTO JSTAN committee. I also want to highlight some of the groups we're working with the Roads and Bridges Industry Committee. Of course, the main AASHTO committees, JTCEES, the JSTAN committee. We've been working with Federal Highway Administration, with several folks there, David Unkelfer and Catherine Petros and others. We're working with these national AASHTO Transportation Pool Fund projects, working with the National Institute of Building Sciences, Roger Gran and his team there, and then many other industry groups such as ACCA and ARCTA. So we're really seeing a lot of good synergy, a lot of good momentum around openBIM and open data standards with these groups. And the last key thing I had is I did want to put on your radar, we have an openBIM transportation summit that's coming up soon. And we plan to do transportation summits at least once a year through buildingSMART USA. This one is going to be August 23rd in Chicago at the Oracle Innovation Labs. And this is really an opportunity on the transportation side to get owners, technology providers, engineers and contractors together, really to talk about openBIM. You know, what are we doing at the national level? What are we doing at the state DOT level? You know, specific project examples, which we call seeing is believing. You know, where are the technology providers going with openBIM? We've had great opportunities, great advancement there, as well as where our Roads and Bridges Industry Committee is going and how to get more engaged. So I definitely want to put this on the radar. There'll be more information on this on our buildingSMART USA website. And we do have sponsorships available for this summit event. I also wanted to highlight some additional events that our committee is involved in. The AASHTO Committee on Design is coming up in early August. And Mike Kennerly is having his Joint Technical Committee on Electronic Engineering Standards meet as part of this conference, and has specifically asked for openBIM to be on the agenda. So I'll be at this meeting, and I believe Ian Howe plans to attend this meeting as well. We've also got the Association of General Contractors IT conference. That's also coming up in August in Chicago. I'll be presenting at that conference as well as another representative with JSTAN. We've got the Utah International Highway Engineering Exchange Program Conference coming up in Salt Lake City. And I'm really excited about this conference. George Lukes with Utah DOT is kind of leading the arrangements on this conference, and they have dedicated a specific track just to talk about openBIM and where we're going with openBIM, with the contractors, with the designers, with the technology providers. So that's going to be very exciting. And then the last thing is just wanted to put on your radar is we have a number of webinars that we've been co-sponsoring at buildingSMART USA. We call these National BIM for Infrastructure webinar series. I've included a link on the slide, but we've done 6 of these webinars. The recordings are available on the link. We do these webinars probably 2 to 3 times a year, and that's another area that to get involved and get engaged. And then I just wanted to share my contact information and also Mike Bosselman's contact information as well. But feel free to reach out to either Mike and I if you want more information on the buildingSMART USA Roads and Bridges Industry Committee or have any questions of us. So with that, I think we're going to jump to Q&A.
Thank you, Will, and thank you, Michelangelo and Mark. It looks like Mark has answered all of the questions that are in the chat window. There was one from Horatio asking any integration being explored with virtual inspection technology such as OpenSpace or site. So Mark had provided an answer. I just wonder if Michelangelo would like to add anything to that.
Yes, I'm finding this in the chart.
Yeah. So the question is, are there any integration being explored with virtual inspection technologies?
Oh, yeah. Yes, at the moment, one of the cool thing about all of these new technologies that are being combined together is the fact that very new use cases are appearing. So we are experimenting a lot, especially with the universities. We have research with the universities and then try to make them real use cases and final products. So yeah, definitely there is a lot of investigation also in that.
Thank you. So I think those are all the questions that are in the chat window. Thank you, everyone. This webinar is recorded and we will post it to the website. We will also send it out through emails and it will be posted to LinkedIn. So keep an eye out for it. Thank you, everybody, for joining us. And thank you, Mark, Michelangelo, and Will for this great webinar.
Thank you for the opportunity.
Thank you.
Thanks, everyone.